Hey everyone, so in this video we're going to be talking about solving applications using systems of equations. Alright, so we're going to jump right into it. The first example is a little bit different because it already has a graph. A lot of the other ones you're not going to have the equations yet. You're not going to have graphs. So for number 1, use the graph at the right to answer the questions below. The x-axis, so that's this one down here, is the price per unit, and the y-axis, that's this one on the left, represents the number of units sold in thousands. The supply and demand equations are graphed, so that's these two lines right here. Alright, so for part A, at what price will the number of units produced equal the number sold? So basically, at what price will the supply equal the demand? All right, well, we just have to look for where these two graphs cross each other. So it's right here. And if we want to know the price, that means we're just going to look downwards and we can get the price. So it would be at $12. All right, let's take a look at part B. So if the price changed to $8, so right here, how many units would be supplied and how much would the demand be for? So for the supply first, all we have to do is look up, find where the supply is, and follow it over and see how much it is. All right, so in this case, it's about 7 units. All right, what about the demand? So the demand is right here. And if we follow it over again, it's somewhere between 9 and 10 units. All right, now the rest of these examples, we're actually going to have to come up with equations and everything ourselves. So let's take a look at example 2. So for example 2, 450 tickets were sold for a total cost of $3,140. If the tickets cost $6 and $8, how many of each type were sold? Alright, so first thing we're going to do is we are always going to figure out what we are actually solving for. Right? In this case, we want to know how many of each type of ticket was sold. So let's let X be the number of $6 tickets and Y be the number of $8 tickets. Alright, so we have two variables. So as you know about systems now, if we have two variables, it means we're probably going to need two equations. Alright, so let's break this down. First off, we know we have 450 tickets that were sold. Alright, so that means the total amount of tickets was 450. Another way to say total is if we add the number of tickets together, it should equal 450. That's our first equation. Our second equation is we know the total cost was $3,140. Well, how do we find the total cost? Well, we can just add up the number of tickets that were sold times how much that ticket costs, right? So X was the number of $6 tickets sold, right? So it's $6 times the number of those tickets were sold, which is just X. Plus, Y was the $8 tickets, so $8 times the number of those that were sold. Y. That should equal our total cost of $3,140. Alright, now it's just a matter of solving this. So you're welcome to solve this any way you would like. In my case, I'm going to put it into an augmented matrix. So 1, 1, 4, 50, 6, 8, 31, 40. Now, if you do Gauss-Jordan elimination or just put it in your calculator, here is the answer you should get. You should get 1, 0, 230, 0, 1, 220. All right, so we know that the 230, that was our x, the 220 was our y. So our final answer, just make sure you write it in English. There was 230 $6 tickets sold and 220 $8 tickets sold. All right, you can't just put x equals 230, y equals 220, because you need to say what those 230 and 220 actually stand for, since we're talking about a real world problem now. All right, let's look at the next one. So Albert bought 360 AA batteries for his organization. The batteries were sold in packages of 6 batteries and 12 batteries per package. A 6-pack of batteries costs $5 and a 12-pack costs $9. The total bill came to $278. How many packages of each type did he buy? Alright, so again, first thing that we're going to do is just say what we're trying to solve for. So we're trying to solve for how many 6-packs and how many 12-packs of batteries they bought. All right, so now we can start putting in our equations. So first thing I notice is this 360. All right, so that's the total batteries he bought. Now, since it is a total, a lot of students want to just say this first. But in this case, because of the wording of the problem, we can't actually put that. Because remember, each X is a pack of 6 batteries. Each Y is a pack of 12 batteries. He didn't buy 360 packs, he got 360 batteries total. All right, so instead of that, if we do 6 batteries per X pack plus 12 batteries per Y pack, that'll give us 360. And then the money can be done very similarly to the last problem. So we know that the 6-pack costs $5. So that's going to be 5x. Plus, we know that the 12-pack costs $9. So 9y equals, the grand total was $278. Right? Setting these up is always the hardest part. From here, it's just solving it. So if I put in an augmented matrix, it's going to be 6, 12, 360, 5, 9, 278. Put this in your calculator or solve it by Gauss-Jordan again, and you should get 1, 0, 16, 0, 1, 22. So we know this is our x and our y. So our final answer is going to be 16 6-packs and 22 12-packs. That's how many of each pack he bought. All right, number 4. The following chart shows the carbohydrates, fat, and protein content in grams of 3 types of food. Okay. A nutritionist needs to prepare a diet from these 3 food groups. The diet must contain 23 grams of carbohydrates, 18 grams of fat, and 39 grams of protein. How many units of each type of food are required for this diet? All right, so for this one, we're just writing the system. We're not actually going to be solving it. But we still have to start out with what are our variables actually going to be. Right? So if it's asking how many units of each type, then that means our variables are going to be each type. So let x be type 1, y can be type 2, and z is going to be type 3. Which is going to be the number of units of each type. Now, we know how many grams of carbs, fat, and protein we want in our diet, right? So let's just look at each of those separately. So if we first look at carbs, we know we want 23 carbs total. So if we look at the first column, this tells us how many carbs are in each type of food. So that's going to be our first equation. So it's going to be 13 times however many type 1 we have, so that was x, plus 4 times however many type 2 we have, y, plus 1, however many type 3 we have, which was z. We want all of that to equal 23. All right, let's look at the fat next. So we know it's 18 grams of fat. So we're going to look at the fat column now. So we have 10 times type 1, which is x, plus 4 times type 2, which was y. Then there's no z's in this case, right? Because it's 0. So in this case, we don't have to put z at all. It's just equal to 18. All right, last one, 39 grams of protein. So we're looking at the protein column now. We're going to do the same thing. So we know it's 13 times type 1 plus 3 times type 2, which is y, and 10 times type 3, which was z. That's going to equal to 39. Those 3 equations give us our system. All right, number 5. Last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Tickets can be bought in one of 3 ways. A matinee admission costs $5, student admission costs $6, and then regular are $8.50. How many of each type of ticket was sold if twice as many student tickets were sold as matinee tickets? All right, so let's start figuring this out. So first off, we're looking for 3 different things: x, y, and z. So we're looking for the number of matinee tickets the number of student tickets and the number of regular tickets. All right, so easiest one first. There was a total of 8,500 tickets sold. So that one's easy. We just have x plus y plus z. The total is 8,500. All right, next up, we know that $64,600 was the total proceeds, which means if we add up the price of each ticket times the number of tickets, we should get that. So matinee tickets were $5, so it's 5x. Student tickets were $6, so that's 6y. And then regular admissions were $8.50, so plus, I'm just going to put 8.5z. If you put 8.50z, that's perfectly fine. It'll be the same thing. That's going to be 64,600. All right, so on to the last equation. For this one, we're going to have to look at the final sentence. So twice as many student tickets were sold as matinee tickets. All right, now the wording in this always trips up students. So real quick, I'm just going to put some numbers on this just so you can see it. All right. So student tickets are y. Matinee tickets are x, right? So if we had, say, 10 matinee tickets, we know that the student tickets are twice as many, so it would be 20. This was 20. It would be 40. Now, what if this was just x? Well, then this would be 2x. So, from there, we can see that y and 2x are the same. So our last equation is y equals 2x, not 2y equals x. Even though the twice as many is right next to the students, you don't actually put the 2 on the y, you have to put it on the x. All right, now if we're going to be doing Gauss-Jordan elimination though, remember we need all the variables on one side. So real quick, I'm just going to subtract 2x from both sides, and we're going to get negative 2x plus y equals 0. And that's going to be my third equation. Negative 2x plus y equals 0. All right, let's go ahead and put this into a matrix. So we're going to get 1, 1, 1, 8,500, 5, 6, 8.5, 64,600, and negative 2, 1, no z's, so I'm just going to put 0, and 0. All right, put this in your calculator now. And if I just move over slightly so I have some more room, you should get 100, 900, 010, 1800, and 001 5800. So our final answer, 900 matinee tickets, 1,800 student tickets, and 5,800 regular tickets. And that is our final answer. Alright, so with that, that's going to do it for part 1. Whenever we come back for part 2, I'll go over the rest of the examples on these notes so you get a lot more practice with this stuff. Okay? So right about now, you should see the card. Just click that. You should be able to go straight to part 2. And I will see you there.